Okay, we are going to start chapter 6, which is just properties of exponents. We are going to cover 3 different learning targets today. The first is that you can use the quotient property to simplify expressions, a product property, and then also the power rule. So that's learning targets 4, 5, and 6. Okay. So this section is going to be split amongst 3 different days. So we do have a lot to get through, but we'll get through them over the course of 3 different lessons and videos. Okay, first one is I can use the product property. Okay, it's important to know that product means multiplication. So this is your multiplication rule. So when you have A be a real number and M and N be integers, to multiply powers with the same base, has to be the same base, here's your rule. You're going to add the exponents. Okay, so what does this look like? If algebraically speaking, if I have x to the m power times x to the n power, all I'm going to do is I'm going to keep the base the same, and I'm going to add those exponents together. Okay, so if I have 2 to the 3rd times 2 to the 4th, this is going to be 2 to the 3 plus 4 power. And 3 plus 4 is 7. So this would be 2 to the 7. Okay, so we have what the rule is. Let's explain why this rule works the way it does. Because if I have 2 to the 3rd power, hopefully we remember that that is 2 times 2 times 2. That's what it means to have 2 to the 3rd power. Have 3 2's all multiplied by each other. Okay, and then if I multiply that by 2 to the 4th power, that's 4 2's. 1, 2, 3, 4. That gets multiplied by each other. So I'm expanding 2 to the 3rd as 2 times 2 times 2, and 2 to the 4th as 2 times 2 times 2 times 2. And when I count all my 2's up, 1, 2, 3, 4, 5, 6, 7. 7 2's all multiplied by each other. That's exactly what 2 to the 7th is. So that's why that works. Okay. So let's go ahead and do some example problems. Okay. So as we work through these, we are going to have some where there are variables and some where there are numbers, and we're going to have to be able to deal with both effectively. So if I have 3 to the 4th times 3 to the 2nd, I'm multiplying. My multiplication rule is to add the exponents. So this is going to be 3 to the 4 plus 2 power. Okay, 4 plus 2 is 6. So this is 3 to the 6th power. And then I also, since this is just a regular number, I would like to know what 3 to the 6th power is. So I'll take 1, 2, 3, 4, 5, 6 3's all multiplied by each other. And when I hit enter, it's 729. Okay, my expectation for you is I'm able to see the base with the exponent and the actual number it's equal to. Okay, 1B. On 1B, we're going to do virtually the same thing. The only thing that makes this one more difficult is that I just have an X. So if I have a number without a variable, it is implied that the variable is 1, or the exponent's variable is 1. So this is actually x to the 9th times x to the 1st. I'm multiplying 2 of the same bases. My multiplication rule tells me to add my exponents. So this is going to be x to the 9 plus 1 power. 9 plus 1 is 10. So this is x to the 10th power. I don't know the value of x, so I can't simplify this down more like I did here. So this is the only thing I need to see as an answer. Okay, it's important to note that if your problem has negative numbers and those negative numbers are in sets of parentheses, they need to stay in those sets of parentheses. So my base is -3, and I'm multiplying. Since I'm multiplying, I keep the base the same, and I'm going to add the exponents. 5 and 2. 5 and 2 is 7. Okay, and this is -3 times 1, 2, 3, 4, 5, 6, 7. Negative 2187 is my answer there. Okay, and again, I would need to see this and this. Okay. What I would suggest you to do is pause the video and then go ahead and try the 3 monitoring progress problems right below, monitoring progress 1, 2, and 3. Okay, assuming that you've already attempted these problems after pausing the video, this is what you get. So you're multiplying, so you add the exponents. Okay, and when you add the exponents, you get to the 7th power. And when you simplify that to the 7th power, you're gonna get negative 16,384. And I need to see this and this. Okay, on number 2, I have 7. Just regular 7 is 7 to the 1st power. So I'm going to keep those bases. I'm multiplying. Since I'm multiplying, I add the exponents together. So 7 to the 1 plus 3 power. 1 plus 3 is 4. So 7 to the 4th power. 7 times 7 times 7 times 7 is 2,401. Okay, monitoring progress 3. When I have just an x, that is x to the 1st power. So I really have x to the 5th times x to the 1st. I'm multiplying. When I multiply, I add the exponents. 5 plus 1 is 6. So this is just x to the 6th power. I don't know the value of x, so I don't know what this is equal to. So its most simplified form is x to the 6th. Okay, let's move on to page 3. Okay, page 3 is now going to deal with learning target 4, which is the quotient property. Okay, it's important to note that quotient property or quotient means division. So this is my division rule. Okay, so to divide powers with the same base, your rule is to subtract the exponents. So this has a nice relationship. Multiplication you add, division you subtract. So here, algebraically speaking, if I have x to the m power divided by x to the n power, this is going to be x to the m minus n power. So you just take the top exponent and you subtract the bottom one. So 5 to the 5th divided by 5 to the 3rd would be 5 to the 5 minus 3 power, which would be 5 to the 2nd power. Okay, so why this works? Well, I can take 5 to the 5th, divide it by 5 to the 3rd, and 5 to the 5th is 5 5s multiplied by each other. 2, 3, 4, 5 5s. 5 to the 3rd is 3 of them. So what is happening here? So imagine I take a number 10, and I take 10 and I multiply it by 2. And then I divide it by 2. What happens? I take a number, I multiply by 10 times 2, 20. 20 divided by 2 is 10. I end up right back over where I started with from the beginning. So whenever I multiply by 5 and divide by 5, it really cancels out to just multiplying by 1. So this here is just the number 1 multiplied by each other. So I'm just going to cross those off because it accomplishes nothing. Just like multiplying by 2 and dividing by 2. They undo each other, and I'm left with whatever I started with in the beginning. So if this multiply by 5, divide by 5 cancels, this multiply by 5 and divide by 5 cancels. And this multiply by 5 and divide by 5 cancels. There's nothing else that cancels, so I just am left with 5 times 5. And 5 times 5 is 5 to the 2nd power. So that's why your subtraction rule works. Okay. Let's go ahead and do some examples. Okay, 2a. I'm multiplying, or I'm dividing. Since I'm dividing, I use my division rule. My division rule says to subtract exponents top minus bottom. So here I have 6 to the 4th divided by 6 to the 3rd. So this is the 6 to the 4 minus 3. Okay. And so then at this point here, I have to subtract these exponents. 4 minus 3 is 1. So I'm 6 to the first power. 6 to the first power is just 6. Okay, so then I have 2b, so I have q to the 6 divided by q. Okay, when I have q to the 6 divided by just q, that is q to the first, just like in the previous page. And then I do the same exact process as what I did before. I just did over here. I'm dividing two of the same bases, so I subtract my exponent top minus bottom. So this is going to be q to the 6 minus 1 power. 6 minus 1 is 5, so this is going to be just q to the 5th power. Okay, 3c, or 2c, I guess this is a typo. 2c is going to be the same thing. The only difference is my base is a negative number, so my base is -6, and it's in parentheses, so my answer when I'm writing it as an exponent needs to be have parentheses around it also. So this is going to be -6, and I'm dividing, so I subtract 7 minus 5. So this is going to be -6 to the second power. -6 to the second power can be determined by taking -6 times -6, which is just 36. Okay. So now that we've gone over 3 examples, what I'd like everybody to do is pause the video and go down and work through these monitoring progress problems. All right, now that I'm assuming that you've already gone through these problems, what I'm going to do is go over them really quick. Here I have x to the third divided by x. So when I'm dividing by x, that means I'm dividing by x to the first. And then I subtract top minus bottom. So x to the third divided by x to the first, which is just x squared. Here, I also have a bottom exponent of 1. So this is -3 to the 5th divided by -3 to the first. I'm dividing, so my exponents need to be subtracted, top minus bottom. Five minus 1 is 4, so -3 to the 4th power. Okay, then I need to figure out what -3 to the 4th power is. -3 times -3 times -3 times -3 is positive 81. And again, I need to see this and this as part of your answer. Okay, 6 bases are the same and I'm dividing, so that means I subtract my exponent top minus bottom. 7 minus 2 is 5. 4 to the 5th power. 4 times 4 times 4 times 4 times 4 is 1024. Okay, that's it for the quotient rule. Okay. Now what we're going to do is power rule. Power rule means I have an exponent raised to a second exponent, as you can see here, exponent to exponent. Okay, so power rule. To find a power of a power is fairly simple. You're just going to multiply the exponents. Okay, and then so when I'm looking at this algebraically, if I have x to the m power divided by x to the n power, I am going to multiply those two to get x to the m times n power. So numerically, if I had x to the second time to 3 to the second to the 4th, this would be 3 to the 2 times 4 power. 2 times 4 is 8. So this would be 3 to the 8th power. Okay, why does this work? Well, if I'm taking 3 to the second power to the 4th power, that's the same as taking 3 to the second times 3 to the second times 3 to the second times 3 to the second. I'm taking 4 3 squareds multiplied by each other. Well, all of those 3 squareds are 3 times 3. So now what I'm going to do is I'm going to break each of these 3 squareds into 3 times 3. And this one's 3 times 3. And this one's 3 times 3. And this one's 3 times 3. So since these are 3 times 3, 3 times 3, 3 times 3, 3 times 3, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. There's 8 3s all multiplied by each other, so that's exactly what 3 to the 8th is. And so that is why your rule works. Okay, last set of examples and monitoring progress problems, and that's it for day 1. Okay, example 3A. I'm taking 5 to the third and I'm taking that to the second power. So that means I need to keep my base the same. And I'm going to multiply my exponents together. So 3 times 2 is 6. So this is 5 to the 6th power. Okay, and 5 to the 6th power is 15,625. And you would do this by taking 5 times 5 times 5 times 5 times 5 times 5. Okay, I'm taking b to the 6th to the 7th. I'm taking a power to a power, so I multiply the exponents. So this is going to be b to the 6 times 7 power. B to the 6 times 7 power is b to the 42nd power. So 42 b's all multiplied by each other. Kind of consistent with all the other previous work. If your number is negative and it's inside parentheses, yours needs to stay the same with that. Okay, so here I'm going to have negative 2 to the 4th to the 2nd, which would be negative 2 to the 4 times 2 power. Power to power, you multiply your exponents. So then here I get negative 2, the 8th power. Negative 2 to the 8th power is going to be a positive 256. All right. Now's the opportunity. Go ahead, pause the video, try 7, 8, and 9, and then check it with me here right now. Okay, so I'm assuming that you've already paused the video at this point and are just looking to see how you did. So 7, I have 4 to the 4th to the 2nd. So this is a power to a power, power to power. I multiply the exponents. 2 times 4 is 8, so this is 4 to the 8th power. 4 to the 8th power is 65,536. Okay, 8, negative 1 to the 7 to the 3rd power. Again, I have a base to a power to a 2nd power. So I'm going to have negative 1 to the 7 times 3 power. 7 times 3 is 21. And negative 21 to the, or negative 1 to the 21st power is negative 1. Okay, 9, I have c to the 11th to the 2nd. So here I have a power to a power, power to power. I multiply the exponents. 11 times 2 is 22. Okay, at this point here, your practice is at the end of day 3. And for day 1's practice, I'd like you to do 23 through 28 all before you progress onto your learning targets.